Number 23 says, write 2,321 in the following numeral systems. And so we have the Egyptian numeral system, the Babylonian numeral system, the Greek numeral system, and the Roman numeral system. So let's start here with the Egyptian. So let's just write down Egyptian. And so to do this one, we write down 2,321. And we're going to look at our formula sheet. So and our formula sheet says, okay, well, how do we represent 2,000? Well, we can draw two lotus flowers. So here are my lotus flowers. And I draw two of those. And so that's 2,000 things. And I need to represent 300 things. So that would be 3 scrolls. So here are my scrolls. 1, 2, and 3. So that's 300 things, and then 20 things. We use 2 heel bones here, and then 1 thing, a vertical staff. And so that's how we would represent 2,321 things using the Egyptian numeral system. And then we're going to do the Babylonian numeral system. All right, so for the Babylonian numeral system, we scroll down here, and here are the Babylonian numerals, and so we have 2,321. And this is actually the hard one. It's so hard because you actually first have to figure out how to write this number base 60. So you have a 1 spot, you have a 60 spot, and then you have a 60 squared spot. But if you notice on your calculator, right, 60 squared is what? So you take 60 and you square it, so raise to the 2. Right, that's 3,600, and that's too big. Right, 2,321 is a lot smaller than 3,600. So we'll start with 60. And so first we have to figure out how many 60s go into 2,321. So I'm going to use my calculator again. So 2,321 divided by 60. And let's just move this over. All right, so what does that equal to? So hit enter. And I get out 38.6 blah 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 blah. Oh no, 2,321. I don't know why I didn't do 21. Right, divided by 60, and you're still going to get 38. Right, so 38 60s will go into 3,221. So how many do I have left over? We'll take 38 times 60, because that's how many things you have represented here. 38 60s. Right, and that's 2,280. So how many things do you have left? We'll take 2,321. and minus 2,280, and you'll see you have 41 things left. So I'll put a 41 right here. All right, so this should represent 2,321 things, and then what I need to do is write these numbers here in the Babylonian numeral system. So this is going to be equal to, well, 38, where's 38? Here's 38 right here, so I write 3 triangular wedges, so 1, 2, 3. And then I write 8 vertical staffs, so 1, 2, 3, 4, 5, 6, 7, 8. Make a nice big space here, and then I do 41 things. So I come over here and look, okay, there's 41. All right, 41's right here. And I draw 4 triangular wedges like this, 1, 2, 3, and then I have 4, and then 1 vertical staff right there. And so that represents 2,321 things. In the Greek numeral system, to write 2,321, to write one thing, let's go down to the Greek numeral system. To write one thing, I write an alpha. So first I write an alpha on the right here. And then write 20 things, I write a 20, which is a kappa, so this K looking like symbol. And then for 300 things, I write a tau. So here's tau. And then for this 2,000, the idea is you reset and you come back here, and for 2,000, that's actually beta. So when you write beta in this spot, it actually represents 2,000 things. And I said in class you have a choice for the comma. The Greeks probably would have written the comma right here, but I'm fine if you want to write the comma here to emphasize that this is actually 2,000. And it kind of connects well with our own numeral system. But again, you could write the comma to the left if you don't want to write it to the right. All right, so that's how we do it in the Greek numeral system. And then finally, if we want to do it in the Roman numeral system, how would we do it? So 2,321. We'll scroll down here to the Roman numeral system, and we have 2,000. So I'll write 2 M's for 2,000. And then I need to express 300, so I'll write 3 C's. And then 20, which I'll write 2 X's. And then a 1. So this represents 2,321 things. All right, on the next page, what do we have? It says here, if a salesperson makes 3.3% commission and they receive $2,400 in commission, how much merchandise did they sell? Okay, so the idea is if you take 3.3% of the merchandise they sell, that should give you the commission. So what I need to do is take how much I sell and multiply it by the percentage, so 0.033, and this should give me my commission, 2,400. And so the amount that I sell, right, the amount that I sell here is equal to 2,400 divided by 0.033. And I take out my calculator and I crunch this number. So let me crunch the number, 2400 divided by 0.033, and it tells me that the amount that I sold is approximately, $72,727 dollars and 27 cents. Right, and 27 cents. Number 25, on this one it says determine whether the reasoning is an example of inductive or deductive reasoning. So Jenny's last 3 meals included eggs, therefore her next meal will include eggs too. So A is an example of inductive reasoning. All right, so remember, inductive reasoning, there are a couple ways to remember this. Oftentimes inductive reasoning can lead to false conclusions. And another way to remember it is that you're going to argue from the specific cases to the general cases in the deductive reasoning. So the specific cases are these 3 meals that Jenny has had, and from that you're making a general conclusion that every meal that follows, in a sense, or the next meal will also be eggs. Now part B, it says John is exactly 3 years older than Jimmy. If John is 24, then Jimmy must be 21. This is actually an example of deductive reasoning. Right, because here you're assuming that, yes, John is exactly 3 years older than Jimmy, so my conclusion, if I know John is 24, I conclude Jimmy is 21. And then C, all my friends hate Tom, therefore I will hate Tom. Again, this is not deductive but inductive reasoning. Okay. Now in 26, this is an optimization problem. I know it's optimization because when I was scanning it here, I saw minimal. So it says you would like to enclose a 480 square foot rectangular region for your dog in your backyard. You would like to fence 3 sides with materials costing $15 per foot, and 1 side with materials costing $10 per foot, and then you want to find the minimal cost. So let's draw a picture. Okay, so I have a rectangular area, and the area A is equal to 480 square feet, so feet squared. You're going to do 3 sides at $15 per foot, and then 1 side at $10 per foot. All right, so let's draw this on the picture here. Let's color code it, right? So we'll do $15 in green, so this will be green side, $15. And then we'll have a blue side, let's say, and that's that $110. And we'll label the sides. Of course, the horizontal will be x, the vertical will be y. So you have x, y, x, y. And you want to find, most important thing to write down really, find min cost. All right, so what are you trying to find? Because that leads to my equation, which is a cost equation, because that's what I'm minimizing or maximizing. And I have to say to myself, if I have x feet here, how much is it going to cost to build this side of the fence, right? Well, it's $15 per foot, and I have x feet, so it's 15x for that side. Plus, for this side, it's 15y. Plus, right, so plus, I have 15x for the other side. And then plus, now it's not 15, and that should be a y. I don't know why that looks like an x. That's not good. So let's make that into a y. And so this side, which is not 15y because it costs $10, so it's 10y. And so c is equal to, we combine like terms, and we get 30x plus 25y. And so you always run into typically the same problem. At this point, you have an equation for the cost, but it doesn't involve one letter. It actually involves two, x and y. So this is a function of two variables. I would like it to be a function of one variable. Then I could graph it and use the maximum or minimum button to find, in this case, I guess, the minimum. And that's where this 480 comes in. So 480 is the area, and the area is the length times the width. So this is x times y. I can solve this for y. So this is y equals 480. Divide both sides by x, right? How do you move it over? You're multiplying here by x, right? X times y. So to move it over, you do the opposite, which is divide. And so I have c equals 30x plus a 25 times 480 over x. And I might clean this up a little bit. So this is equal to c 30x plus, and I can use my calculator to figure out what 25 times 480 is. So plus 12,000 all divided by x. And now to solve this, I'm going to graph it. So I hit y equals, and I plug in 30x, and I have plus 12,000 divided by x. And I'm going to make my window. So there's my window. And here I have to think, okay, x is the length of one side. So let's go from 0. Let's go from 0 to, let's do 100 feet. Why not? And we'll do zoom, zoom fit, and just see what happens. So it goes down, oh, and it comes back up. All right, so it goes like this from 0 to 100. It comes down and eventually goes back up. I'm looking for this minimum value, so I'm going to use the minimum button. So I hit second trace to pull up the calculate menu, and I go down to minimum, which is number 3. Left bound. Oops, I hit the wrong numbers. Okay, so I had to start over. That's okay. So on this one, I'll hit second trace. I have to start over here, 3. And it says left bound. Now for the left bound, before I hit enter, I better put it in. So I'll hit 0, because 0 is definitely to the left. You can see here, here's 0. And then for right bound, 100 is definitely to the right. So hit enter there, and then 100, enter. And then for a guess, just hit enter, and it'll jump right to it. So in this case, it says x is 20, and y is 1200. And now be careful, the y here and the y up here are not the same thing, right? The input is x, and that is the same thing as our x here, but the output y is actually the cost. So our minimum cost, which is what we're trying to find, is $1,200. All right, and then the last step is test, but really we're testing it here by graphing it. So as long as it makes sense, and that's good enough for me, we'll just stick with the $1,200. All right, on the next question, 27, is a question about probability. So on here, it says a card is drawn from a 52 card deck, and we want to compute these different probabilities. So first, a probability of getting a spade, and the card is black. Right, now and, right, here's our A actually. Right, and is intersect, and that's our B. And then here we have, again, getting a spade, and then part B, or our card is black. So in this one, this is our A, and or is a union, and this is our B. And then finally in C it says find the probability of getting a spade, so getting a spade is our A, given that, and so given that means we draw this line, the card was black. Alright, so let's do these. In part A, it's the probability of A intersect B. And we have to be careful here. I'm not sure if the events are independent or not. If they're independent, you can use the formula, but I'm not going to assume that. What I'm going to do is just count the number of things in A intersect B, all divided by the number of things in my sample space S. So A is getting a spade, and so there are, 13 spades? Right, so if you want, you can write over here A is equal to, and there are 13 spades. All right, in B, how many black cards are there? Well, there are lots of black cards. Half of them are black, so there's 26 black cards. And if you think of A intersect B, the probability, the number of things in the set of A intersect B these are the number of spades that are also black. Well, all the spades are black, so the number of things in A intersect B is 13, all the spades, divided by 52. And so that's equal to 1/4. Right, so you have 1/4 of a chance of drawing a spade and a black card. Part B is the probability of drawing a spade or a black card. And remember, that's equal to P of A plus P of B minus P of A intersect B. And so the probability of drawing a spade is, of course, 13 over 52. There's only 13 spades. Plus the probability of drawing a black card, which is 26 over 52 because half the deck is black. And then minus their intersection, and I'm not going to use 1/4, I'm going to use 13 over 52. Which is equal to, the 13 over 52's cancel, and you're just going to get 26 over 52 over 52, which is equal to 1/2. Again, you could say up here, or 25% of the time, and here you could say, or 50% of the time. Okay, and then finally in part C, we want the conditional probability, so probability of A given B has already occurred, which is equal to, you can look at the formula, and it's P of A intersect B divided by P of B. P of A intersect B was 1/4. And P of B, the probability of getting a black card, is 26 over 52, which is 1/4 times 52 over 26, which is equal to, well, 52 over 26 is a 2, so you get 1/4 times 2, which is equal to 2 over 4, which equals 1/2. So what's the probability that you get a spade given the card was black? Well, if you have the black cards, the only black cards are spades and clubs. And 1/2 of them are spades and 1/2 of them are clubs. So now the probability that you get a spade is exactly what you think. 1 over 2, 1/2. All right, number 28, we have perform the following operations by hand and make sure you show your work. So let's start on the left here. And this is all, please excuse my dear Aunt Sally. All right, remember, these two can go together, and these two can go together. P stands for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. And so what we need to do here is start with the parentheses, which are the absolute values. Can be considered like parentheses. So we'll start with the absolute value, and inside here we have subtraction and multiplication. So we start with the multiplication because it's above in the order of operations. So this is 6 minus 24 minus 5 squared. So that's what that's equal to. And then that's equal to, so 6 minus 24 is a negative 18. So we have absolute value negative 18 minus 5 squared, which is equal to the absolute value of a negative number makes it positive. So positive 18 minus 5 squared, which is equal to 18 minus, now do the exponent, so 25, which is equal to 18 minus 25. Well, 18 minus 25 is a negative 7. Right, so my answer should be negative 7. On the right-hand side here, on part B, again, start with the parentheses. So I have these parentheses, and I go inside, and then I have those parentheses. This is negative 14 divided by 7 minus 5 times, and negative 7 minus 9 is a negative 9, or negative 7 minus 2, sorry, is a negative 9. And then I add 2 on the end. Again, I'm working inside the parentheses, so I have minus 14 divided by 7 minus a 5 times negative 9 is a negative 45 plus 2. There are a couple things I can do here if you want. I could start here and do this negative negative, I guess. Kind of keep working with the parentheses in a way. So negative negative is a positive 45 plus 2. All right, so now I'm done. And so what can I do now? Well, I look through my order of operations. I have addition, addition, and division. And I do division first. So this is equal to minus negative 14 divided by 7, negative 2, right? Plus 45 plus 2. And then I can do the addition if you want. All right, so the addition gives me to 43. Then I add 2, which gets me back to the 45. So 45 is my answer for this one. On number 29, it says use inductive reasoning to determine the next term in the sequence, and use deductive reasoning to classify the sequence as arithmetic, geometric, or neither. All right, so in this one, let's start with part A. I have 5, 15, 37, 77, and 141. Well, if I notice, I'm adding 10 here, but I'm certainly not adding 10 to get to 37 here, so it can't be adding, so it's not arithmetic. And then I'm multiplying by 3 to get here, but certainly if I multiply this by 3, I get 45, so it's not geometric. It must be the one that is neither. And so I can take 5, 15, 37, 77, and 141, and I can conclude that this type of sequence is neither arithmetic or geometric. And then I can find the next term in the sequence by using this method of successive differences, or what I like to call the web. So the idea is you subtract these numbers. So take 15 minus 5, which is 10. 37 minus 15, which is 22. 37 or 77 minus 37, which is 40. And then 141 minus 77, which you could check on your calculator, is 64. And then I do the subtraction again. So this is actually 12. This one is 18. And this one is 24. And finally, I take these two differences. 18 and 12 is 16. 24 minus 18 is not 16, but 6, right? And so then I can make my next term. Right? My next term would be what? Well, I need to get a 6 here. So what minus 24 gives me 6? Well, that would be a 30. And then I need a 30 here, so that would be 94. And then here, I need to put a number here. Then I subtract from 141, I get 94. Well, I can use my calculator to help me here. So what number minus 141 equals 94? That's the same as saying if I add 94 to 141, I'll get that number. So take 94 plus 141, and you'll see you get 235. And that's my answer. So if I take 235 minus 141, it should give me 94. On part B, I have 2, 6, 18, 54, 162, and it seems like I'm multiplying by 3 each time, right? 2 times 3 is 6, times 3 is 18, times 3 is 54, and I'm guessing 54 times 3 is 162. Great, so the next term, I would take 162 times 3, and that would be 486. And because I'm multiplying, this is an example of a geometric series. On part C, we have 3, 8, 13, 18, 23, ... And on this one, I'm guessing this is arithmetic. So if it's arithmetic, I'm adding, and it looks like I'm adding 5 each time, right? If I add 5 to 3, I get to 8. Add 5, I get to 13. Add 5, 18. Add 5, 23. So add 5 to 23, and I get to 28. So next term, I'm guessing I'm using my inductive reasoning skills, going from the specific examples given here to conclude the next term is 28. And then I'm using my deductive reasoning skills to classify this as an arithmetic sequence, because I know if I'm adding a term each time, I'm adding a number to get the next term each time, that's called an arithmetic sequence. Whereas if I multiply by the same number each time, I call it a geometric sequence. Geometric series, I'm sorry. I should change this. That's wrong. There's something else in mathematics called a sequence. This is a series. This is a sequence, not a series. All right. Oops. All right. So these should be sequences. Yeah. All right. So this is a geometric sequence, and this is an arithmetic sequence, not a series. So forget I said series. That's something else. All right. Number 2, which actually should probably be what, number 30, I guess. All right, it shouldn't be number 2, but number 30 is a typo. That's okay. If you deal out 5 cards, determine the probability that you deal 4 aces. All right, so what we have here is first we have to basically count how many 5-card hands we have. So let's think about that. S is our sample space. And so how many things are in S? We have 5 spots. All right. Remember, you have 52 cards total. And so how many different possible hands do you have? Well, when you deal out cards, you have 52 choices, 51 choices, 50 choices, 49 choices, and 48 choices here. Right, but then you have to be a little bit careful because there's some hands you're going to be counting more than you would like. As an example, if you had the 2, 3, 4, 5, and 6 of hearts, and you rearrange these cards, that's still the same hand. So the idea is you do have 52 times 51 times 50 times 49, but then you have to divide out, right, by the different ways there are to rearrange 5 things, which is 5 times 4 times 3 times 2 times 1. And if you do this on your calculator, it'll tell you. So it'll tell you what this is actually equal to, if I can get this to move over. All right, so on my calculator, you're going to take, let's clear this out, you're going to take 52 times 51 times 50 times 49, and then times 48. And then you're going to divide by left parenthesis, because this is all on the bottom, 5 times 4 times 3 times 2. And you really don't need to put times 1, but I will. So times 1, hit enter. And so there are 2,598,960 possible different 5-card hands. And now I have to count the number of things in my event space. Now my event space is that you deal 4 aces. So the idea is I have 4 aces, and you can draw them, right? I have an ace of, let's do hearts, an ace of diamonds, an ace of clubs, and an ace of spades. And I have one other card, right? So how many cards could I put here? Well, there are 48, as I've already used 4. And so if I count all these up, you can see obviously there's one choice here, one choice here, one choice here, one choice there. So that's given. And there are just 48 different hands. Right? All the hands with all the 4 aces, and then one extra card. And so in this case, you get 48. And so the probability that E occurs is just equal to the number of things in E divided by the number of things in S, which is 48 divided by 2,598,960. And we can see if we can simplify this by putting 48 into this 2,598,960. So let's see if that goes in that. So let's divide it by 48. And it does go into it. So this is actually 1 over 54,145. And so that's my answer. I don't even think I want to do the decimal because it's going to be so small. But let's see what it would be equal to. Second answer. Yeah, so that's awfully small. So I'm going to ignore the percentage, right? It's something like, point what, 000, right? So about 0.01% or something like that, 0.02%, I think. Yeah. So I'm just going to leave it as 1 divided by 54,145. Remember, E means times 10, and negative means move the decimal place to the left 5 places. So it'd go 1, 2, 3, 4, 5. And so, I mean, you could say this, actually, if you really want to, you could actually say this is approximately 0.12345 with a 2, because we'll round up. And then you could move the decimal place over twice, and it's even worse than I thought, right? 0.002% of the time. All right, the next problem, we're back to financial mathematics here. And on this one, what do we have? It says here's the future value, present value, and simple interest. And what is the time? So pick the right formula. So let's pull up the formula sheet if I can find it. Here it is. And then I scroll all the way down here. Since it says simple interest, I know I need to use a simple interest formula. So let's copy it down. Future value equals present value times 1 plus IT. And let's plug in. The future value was 4470 equal to 3,000. That's a present value. I have 1 plus the simple interest rate is 7%, so 0.07. And then I have a t here. And I'm looking for t. Right, so to find t, I'm going to graph the right, graph the left, and intersect. So I'm going to take my calculator and hit y equals and clear all this out. And I'll graph the right, which is 3,000, left parenthesis 1 plus 0.07x, in parenthesis, then hit enter and 4470 and for y2. And then I'm going to make my window. Now here's where I have to think a little bit. So where do you want to make your window from? Well, let's go from 0 to 10 years and see what that does. Right, it's not a lot of money, so I would expect it to be paid back within 10 years. So let's do 0, enter, 10, enter, and then zoom fit it. And so I get a line, and then there's the horizontal line, which represents a 4,470. And to find where they cross, where they intersect, I'm going to use the intersect button. So I hit second, trace, go down to number 5, which is intersect, and just hit enter 3 times. And I get out x equals 7 and y is 4,470. So x is actually my t, it's my input. So t is equal to exactly 7 years. The next table problem in the financial mathematics section has to do with, it says future value, present value, continuous interest rate, and time. And so you can look at your formula sheet, and it'll tell you that the formula for the continuous interest formula is FV equals PV, e to the IT, and then you just plug in accordingly. I don't know what FV is, so let's just leave it FV. Equals PV is 13,000, and I have e to the 9%, so I write 0.09, and then times 5. And I can just crunch this on the clear screen, so let's clear it out. And I just put 13,000, second ln, 0.09 times 5, and parenthesis, hit enter, and out pops my answer. It's approximately $20,388.06. All right, so here's my answer. And I guess if you want, you could put that in here, right? So $20,388.06. And the last problem we have to do says future value payment, nominal interest rate, compounded time. So since it says future value, and if you look at your formula sheet here, so I pull up my formula sheet, there's only one that has a payment and then future value, and that's a future annuity formula. So let's copy down the formula. FV equals the payment times N over I, all times 1 plus I over N to the NT minus 1. And so I'll plug in the correct numbers here. So the future value is 14,650. The payment is P, I don't know that, times the number of payments I make, or the number of times I compound interest, same thing, that should be monthly, so times 12, divided by the interest rate, which is 0.08, And then this is 1 plus 0.08 divided by 12. All raised to the 12 times how many years? It looks like 4 years minus 1. And the idea is I need to find p, so I'll graph the right, graph the left, and intersect. So clear all this stuff out and plug it in. So I have p, which is x, and then I have 12, so 1, 2, divided by 0.08, left parenthesis, 1 plus 0.08, divided by 12, in parenthesis and raised to. And now here you have to be careful. If you enter 12 times 4, you're going to have to put parentheses around it. So to avoid that, I know 12 times 4 is 48, so I'll just hit raised to the 48 minus 1 in parentheses. And then for y2, I'll put 14,650. Then I'll hit the window button, and now I have to think again. So what do I want my payments to be? Well, I'm guessing that it's somewhere bigger than 0, so I'll start at 0. And I'll go up to, well, you have to guess what's a reasonable payment on $14,650 in a sense. Well, I'd say maybe $500 a month. Right? I think it's going to be less than that. Hit zoom fit. And if it's not, we can make our window larger. But I think 500 will be just fine. And so I hit zoom fit, and I wait. And here slowly, it draws my graph, which looks something like this. And then when it gets to the end, it should put a line through there, something like that probably. And I'm going to intersect to find where they cross. Yep, there it is. All right, so I hit second, trace, go to number 5, which is intersect, hit enter 3 times, and it's going to tell me my payment P is about $259, and it looks like 98 cents. All right, so up here, all right, so here's my answer, and up here I guess I could write $259.98.